Lesson 2 Indices and Surds. Hello everyone, my name is Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from us. The learning objectives of this lesson are to understand the relationship between surds and fractional indices, to understand the four operations on indices and surds, to rationalize the denominator of an expression involving surds, to solve equations involving indices and surds. Let's recall some of the important concepts that you should have learned these in elementary mathematics. Rational numbers. Rational numbers are numbers that are in the form of a over b, where both a and b are integers and b is not equals 0. Examples are 3, half, 9 over 4, negative 2 over 3, 0, etc. are rational numbers. Index notation, a to the power of n, where n is positive integer. When a to the power of n is equal a times a times a multiplied by itself for n times. A is called the base or body, and n is called the power, index, or exponent. Now, let's discuss a few important laws of indices with proofs. Law number 1. A to the power m multiplied by a to the power n equals a to the power of m plus n. So let's look at the proof. Example, 2 to the power of 4 times 2 to the power of 3. It means 2 times 2 times 2 times 2 multiply itself 4 times, then multiply again 2 times 2 times 2, or the 2 multiply itself 3 times. We can count that there are 7 times the 2 multiply itself, which is 2 to the power of 4 plus 3. Law number 2. A to the power m divided by a to the power n equals a to the power m minus n. So this law is quite similar with law number 1. Here is the proof. Example, 2 to the power 4 divided by 2 to the power 3. So it means 2 multiply itself 4 times divided by 2 multiply itself 3 times. Or we can put it in a fraction form and we can cancel them one by one. At the end, we get 2 to the power 1, which is 2 to the power 4 minus 3. Law number 3. A to the power m times b to the power m equals bracket ab to the power of m. Now let's look at the proof. Let's say we have 2 to the power 4 times 3 to the power 4. It means 2 multiply itself 4 times 3 multiply itself 4 times. We can rearrange the equation and becomes 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3, or 2 times 3 to the power 4. Law number 4. A to the power m divided by b to the power m equals bracket a over b to the power m. This law is similar with law number 3. Let's look at the proof. We have 2 to the power 4 divided by 3 to the power 4. It becomes 2 multiply itself 4 times divided by 3 multiply itself 4 times. And we can put them into the fraction form, and we get 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3, which is 2 over 3 to the power of 4. Law number 5. Bracket a to the power m to the power n equals a to the power of m times n. This law sometimes is called open bracket law, as we remove the bracket. Now let's look at the proof. 2 to the power of 3 to the power of 4. It means inside the bracket 2 multiply itself 3 times, outside the bracket to the power of 4. So it means that the bracket multiply itself 4 times. And we can calculate how many times the 2 multiply itself. For this case, the 2 multiply itself for 12 times, which means 2 to the power of 3 times 4. Law number 6, the zero power law, which is a to the power of 0 equals to 1, where a cannot be 0. Now let's look at the proof. We can just take any number, for example, 2 to the power of 4 divided by 2 to the power of 4. So it means 2 multiply itself 4 times divided by 2 multiply itself 4 times, which we can put in a fraction form and cancel 1 by 1. What happens is 2 to the power of 0 equals 1. Do take note that 0 to the power of 0 is not equal to 1. 0 to the power of 0 is not equals 0 as well. Hence, 0 to the power of 0 has no solution. Law number 7. A to the power of negative n equals 1 over a to the power n. Now let's look at the proof. Let's say 2 to the power of 2 divided by 2 to the power of 4 equals 2 multiply itself 2 times divided by 2 multiply itself 4 times, which for the division it becomes 2 to the power of 2 minus 4 equals 2 times 2 divided by 2 times 2 times 2 times 2, and we can cancel each of the 2 here, and 2 to the power of negative 2 equals 1 over 2 squared. Law number 8. A to the power of 1 over m equals m root of a. Let's look at the proof. If 4 to the power of half times 4 to the power of half, based on the first law, it can be 4 to the power of half plus half, which gives us 4 to the power of 1. We also know that square root of 4 times square root of 4 equals 2 times 2, which gives us 4. Hence, 4 to the power of half equals square root of 4. Now, let's try another example. Like 8 to the power of 1 over 3 times 8 to the power of 1 over 3 times 8 to the power of 1 over 3, and we get 8 to the power of 1 over 3 plus 1 over 3 plus 1 over 3, where we apply law number 1, and we get 8 to the power of 1. We also know that cube root of 8 times cube root of 8 times cube root of 8 equals 2 times 2 times 2, which gives us 8. Hence, 8 to the power of 1 over 3 equals cube root 8. Now, let's look at this additional law, which is a to the power mon equals n root of a to the power m equals n root of a to the power m. This equation is the combination of law number 5 and number 8. Now let's look at some proof. A to the power mon is equal to a to the power m times 1 over n. By applying law number 5, it becomes a to the power m to the power 1 over n, which means n root of a to the power m. Also, a to the power m over n equals a to the power 1 over n times m, or equals, apply law number 5, inside bracket a to the power 1 over n, outside bracket to the power m, which means n root of a to the power m. Let's try with numbers. 9 to the power 3 over 2 equals surd 9 cube, which is surd 729, and the answer is 27. Or we can rewrite, it becomes 9 to the power 3 over 2 equals surd 9 cube, which will give us 3 cube, and the answer is 27. In summary, law number 1 is a to the power m times a to the power n equals a to the power m plus n. Law number 2, a to the power m divided by a to the power n equals a to the power m minus n. Law number 3, a to the power m times b to the power m equals bracket ab to the power m. Law number 4, a to the power m divided by b to the power m equals bracket a over b to the power m. Law number 5, bracket a to the power m to the power n equals a to the power m times n. Law number 6, a to the power 0 equals to 1. Law number 7, a to the power negative n equals 1 over a to the power n. Law number 8, a to the power 1 over m equals m root of a. You need to memorize these 8 laws. An additional law is a to the power m over n equals n root of a to the power m equals n root of a to the power m. So the first 2 laws have the same base, different power. Law number 3 and number 4 have the same power but different base. At this level, you should be familiar with all the laws of indices. Now, let's apply these laws. Let's look at this example. Simplify the following expressions. You are given 2 expressions with indices that need you to simplify. Here are some tips for you to get your final answer. Number 1, your answer should have only positive powers. It should have no repeated unknowns. It should have only one constant if there's any. And it can be in the form of m root a where necessary. Here is the solution for this example. For the first expression, the first step we can do is change the negative power to become positive power. Hence, it will become x over y cubed to the power of 2 times y to the power of 4 over x cubed to the power of 2. Next, we can remove the bracket and it will become x squared over y to the power of 6 times y to the power of 8 over x to the power of 6. Then we can combine the like terms. For this case is x to the power of 2 minus 6 times y to the power of 8 minus 6. And we get x to the power of negative 4 times y squared. And the final answer is y squared over x to the power of 4. For the second expression, we can firstly change the divide sign to multiply sign, and the power half becomes square root. Then the negative power becomes positive power by switching the position of the numerator and the denominator, which becomes 64 p to the power of 6 q cubed over 125 to the power of 2 over 3 times 1 over 4 pq to the power of 3 over 2. Then we can start to remove the bracket. Firstly, we can take care of the 3, which become cube root of 64, which is 4. Cube root for 125 is 5. And for the remaining power, you can divide by 3, which becomes p squared and q. Next, the square. So 4 squared becomes 16, 5 squared becomes 25, and the power you can multiply by 2 becomes p to the power 4 and q squared. Now, we can separate the constant as the first fraction and the terms with unknown as the second fraction. When they combine, it becomes 64 over 25 times p to the power 4 minus 1, q to the power 2 minus 2 over 3, and finally, the answer is 64 over 25 p cubed q to the power 4 over 3. Now, here is another example that you can try it yourself. Simplify the following expressions. This is the first expression and this is the second expression. You can pause the video and try to do it yourself. And this is the answer. Do you get the answer correctly? Now, this is another example. Expand the following. So this is the first one. Bracket x to the power of half plus 3y to the power of half square. Number 2, bracket p to the power of 2 over 3 minus q to the power of 1 over 3. Another bracket p to the power of 4 over 3 plus p to the power of 2 over 3 q to the power of 1 third plus q to the power of 2 third. So the solution is this. Recall the formula a plus b square equals to a square plus 2ab plus b square. Hence, for the first expression, when we expand by applying the formula, this is what we get. And simplify, we get this. X plus 6x to the power half, y to the power of half plus 9y. For the second expression, we can expand the two brackets using the rainbow method. So the first term multiply with the first term for the second bracket, and we get this. Continue to expand, and we get the second term, and we get the third term. We get the fourth, fifth, and finally the sixth term. Now we can start to simplify them, and this is what we get. So the answer will be p squared plus p to the power 4 over 3 q to the power 1 over 3 plus p to the power 2 over 3 q to the power 2 over 3 minus p to the power 4 over 3 q to the power 1 over 3 minus p to the power 2 over 3 q to the power 2 over 3 minus q. And we can cancel the like terms. And finally, our answer is p squared minus q squared. Here is another example that you can try it yourself. Expand the following. This is the first expression and this is the second expression. You can pause the video and try to do it yourself. And this is the answer. Do you get it correct? Here is the example of applying the laws of indices to solve an equation. Given that 3 to the power of 2x plus 4 times 5 to the power of x minus 2 equals 27 to the power of x times 5 to the power of 2x, find the value of 15 to the power of x. The solution for this example is, from the given equation, we can apply the first and the second law. When the power is plus, we can change it to become multiply. When the power is minus, we can change it to division. For 27, we can change it to 3 cubed. For 5 to the power 2x, we can change it to 5 to the power x bracket square. Next, we can change the 3 to the power 2x becomes 3 to the power x square. For 3 to the power 4, the answer is 81. For 5 square, it is 25. For 3 cube to the power x, we can change it to 3 to the power x cube. Next, we can put the terms with unknown x to left hand side and the constant to right hand side. Then we can remove the bracket and simplify. The equation becomes 1 over 3 to the power x times 1 over 5 to the power x equals 25 over 81. And we can combine them together. Since 3 and 5 have the same power, we can multiply them together. 3 times 5 to the power x equals 81 over 25. And the answer for 15 to the power x equals 81 over 25. Here is another similar example that you can try yourself. Given that 2 to the power 3x times 3 to the power 2x equals 2 to the power 2x plus 3 times 3 to the power x minus 1. Find the value of 6x. You can pause the video and try to do it yourself. The answer is 8 over 3. Do you get answer correctly? Let's look at several examples related to equations involving indices. Solve the following equations. A. 2 to the power 3 minus 2x equals 64. B. 25 to the power 2x plus 5 equals 5 to the power x over 125. The solution for A, 2 to the power 3 minus 2x equals 64. We can change the 64 to 2 to the power 6. And from here, both sides have the same body. Therefore, we can compare the power, which is 3 minus 2x equal to 6. We solve this equation. 2x equals 3 minus 6, and the answer for x is negative 3 over 2. For B, 25 to the power 2x plus 5 equals 5 to the power x over 125. We can rearrange the equation becomes 5 squared to the power 2x plus 5 equals 5 to the power x over 5 cubed to the power half. And rewrite the equation, we can get both sides have the same body. Then we can compare the power, which is 4x plus 10 equals x minus 3 over 2. We solve this equation and we get x equals negative 23 over 6. Here is one similar example that you can try yourself. Solve the following equations. A. 9 to the power of x minus 1 equals 243. B. 49 to the power of 3x plus 2 equals 343 to the power of x over cube root of 7. You can pause the video and try to do it yourself. The answer for A is 7 over 2, B is negative 13 over 3. Do you get the answer correctly? Here is an example related to quadratic equations involving indices. Solve the equation 2 to the power of 2x plus 1 equals 5 times 2 to the power x plus 12. The solution for this example is, from the equation 2 to the power of 2x plus 1 equals 5 times 2 to the power x plus 12. We can rewrite the equation becomes 2 to the power of 2x plus 2 equals 5 times 2 to the power x plus 12. And rewrite the equation for 2 to the power 2x, we can write it becomes 2 to the power x squared. We can bring the 5 times 2x to the left, and plus 12 to the left becomes minus 12. Then we can substitute 2 to the power x equals to y. The equation becomes 2y squared minus 5y minus 12 equal to 0. We solve this quadratic equation, which will become y minus 4 times 2y plus 3 equal to 0, y minus 4 equal to 0, or 2y plus 3 equal to 0, y equal to 4, or y equals to negative 3 over 2. We substitute back the y becomes 2 to the power x equals 2 squared. The x will equals to 2, or 2 to the power x equals negative 3 over 2, which is not possible, and we'll reject this answer. Let's try one example yourself. Solve the equation 2 to the power 2x plus 3 plus 23 times 2 to the power x equals to 3. You can pause the video and try to do it yourself. The answer is x equals to negative 3. Properties of surds. From law number 3, a to the power m times b to the power m equals bracket ab to the power m. Law number 4, a to the power m divided by b to the power m equals bracket a over b to the power m. From these two laws, we can derive the properties of surds. The first property is surd A times surd B equals surd A times B. The second property is surd A over surd B equals surd A over B, where the A and B must be greater than 0. Here's an example in simplifying surds. Express the following as surds in the simplest form. A. Surd 72, B. Surd 192. You should get the answer without using calculator. The solution for this example is, for A, surd 72 can be written as surd 36 times 2, which will become surd 36 times surd 2, and the answer is 6 surd 2. For B, surd 192 equals surd 64 times 3 equals surd 64 times surd 3, and the answer is 8 surd 2. Here is one example that you can try it yourself. Express the following as surds in the simplest form. A. Surd 63, B. Surd 275. You can pause the video and try to do it yourself. The answer for A is 3 surd 7, for B 5 surd 11. Do you get the answer correctly? Now, let's discuss the addition and subtraction of surds. When two surds are expressed in the same surd factor, they are called like surds. For example, 2 surd 3, 5 surd 3, and even 2 surd 3 over 3 are like surds with the surd factor of surd 3. When two surds cannot be expressed in the same surd factor, they are called unlike surds. Examples are 3 surd 2, 3 surd 5, and 2 surd 7 over 3 are unlike surds. Like surds can be simplified to a single surd by adding or subtracting them. Examples are 5 surd 3 plus 2 surd 3 equal 7 surd 3. 5 surd 3 minus 2 surd 3 equal 3 surd 3. Now let's look at one example that we can apply addition and subtraction of surds. Simplify the following expressions. A. Surd 108 plus surd 147 minus surd 48. B. Surd 150 minus Surd 112 plus Surd 252. Here is the solution. For A, Surd 108 can be written as 36 times 3. Surd 147 can be written as 49 times 3. Surd 48 can be written as 16 times 3. And it can be simplified as 6 Surd 3 plus 7 Surd 3 minus 4 Surd 3. The surd factor is Surd 3. Therefore, it can be written as 6 plus 7 minus 4 Surd 3. And the answer is 9 Surd 3. For B, Surd 150 can be written as 25 Surd 25 times 6. Surd 112 can be written as Surd 16 times 7. Surd 252 can be written as 36 times 7. And we'll get 5 Surd 6 plus 4 Surd 7 minus 6 Surd 7. And the answer will be 5 Surd 6 minus 2 Surd 7. Here is one example that you can try it yourself. Simplify the following expressions. A. Surd 72 plus Surd 128 minus Surd 162. B. Surd 448 minus Surd 180 plus Surd 63. You can pause the video and try to do it yourself. The answer for A is 5 Surd 2, B is 11 Surd 7 minus 6 Surd 5. Let's talk about multiplication of surds. Recall that one of the properties of surds as surd A times surd B equals surd A times B. When surd A times surd A equals surd A times A, we'll get surd A squared. Therefore, surd A times surd A will be equals to A. Here is an example that we can apply multiplication of surds. Simplify the following expressions. A. Surd 14 times surd 6. B. Bracket 7 plus surd 3. Bracket 4 minus surd 3. The solution for A is surd 14 can be written as surd 7 times 2. Surd 6 can be written as surd 3 times 2. And we can break the surds becomes surd 7 times surd 2 times surd 3 times surd 2. We can combine the surd 2, it becomes surd 2 times 2 times surd 7 times 3, and the answer is 2 surd 21. For B, we can apply the rainbow method. It becomes 7 times 4 minus surd 3 plus surd 3 times 4 minus surd 3, and expand the bracket. We get 28 minus 7 surd 3 plus 4 surd 3 minus surd 3 times surd 3. Simplifying further, we'll get the answer is 25 minus 3 surd 3. Here is the example that you can try yourself. Simplify the following expressions. A. Surd 15 times surd 21. B. Bracket 6 plus surd 5. Bracket 9 minus surd 5. You can pause the video and try to do it yourself. The answer for A is 3 surd 35. For B is 49 plus 3 surd 5. Do you get the answer correctly? Here is more example of multiplication of surds. Simplify the following expressions. A. Bracket 7 plus 2 surd 3. Bracket 7 minus 2 surd 3. B. Bracket 7 surd 2 plus 5 surd 3 square. The solution for A is, recall that A plus B times A minus B equals A squared minus B squared. We can apply the formula for A. It becomes 7 plus 2 surd 3, 7 minus 2 surd 3 equals 7 squared minus 2 surd 3 squared. We get 49 minus 2 squared surd 3 squared, and the answer will be 37. For b, recall that a plus b squared equals a squared plus 2ab plus b squared. Therefore, 7 sub 2 plus 5 sub 3 squared will be equals 7 sub 2 squared plus 2 times 7 sub 2 times 5 sub 3 plus 5 sub 3 squared. Then we can simplify the equation. It becomes 98 plus 70 sub 6 plus 75, and the final answer is 173 plus 70 sub 6. Here is another similar example that you can try yourself. Simplify the following expressions. A bracket sub 5 plus 2 sub 7 bracket sub 5 minus 2 sub 7. B bracket 8 sub 6 minus 4 sub 7 square. You can pause the video and try to do it yourself. And the answer for A is negative 23, for B is 496 minus 64 sub 42. Division of surds and rationalization. When we divide a number by a surd, for example, 3 over surd 2, or simplifying a fraction with a surd in its denominator, for example, 3 over 5 plus surd 2, we usually simplify the answer such that the denominator does not contain any surds. This process is called rationalization. Examples are 3 over surd 2. We can multiply surd 2 at the top and surd 2 at the bottom, which will become 3 times surd 2 over surd 2 times surd 2, and it is simplified to 3 surd 2 over 2. You can notice that there is no surd at the denominator. This is another example, 3 over 5 plus surd 2. What we can do is, we can times 5 minus surd 2 at the top and times 5 minus surd 2 at the bottom, which will get 3 bracket 5 minus surd 2 over 25 minus 2, and we can simplify, it becomes 15 minus 3 surd 2 over 23. You can also observe that this example there is no surds at the denominator. Here is the example for division of surds and rationalization. Rationalize and the denominator of each of the following. A 9 over 2 surd 3, B 7 surd 2 over surd 125. The solution for A is, we can multiply the surd 3 at the top and at the bottom. We'll get 9 surd 3 over 2 times 3. And the answer is 3 surd 3 over 2. For B, 7 surd 2 over surd 125, we can rewrite becomes 7 surd 2 over surd 5 square times 5, and we get 7 surd 2 over 5 surd 5. Now we can multiply surd 5 at the top and multiply surd 5 at the bottom. We'll get 7 surd 10 over 5 times 5, which the answer is 7 surd 10 over 25. Here is one example that you can try yourself. Rationalize the denominator of each of the following. A 3 over surd 6, B 9 surd 11 over 4 surd 5. You can pause the video and try to do it yourself. The answer for A is surd 6 over 2, B 9 surd 55 over 20. Now, let's look at another advanced example of rationalization. Rationalize the denominator of each of the following. A 9 minus surd 3 over 2 plus surd 3. B 7 surd 3 plus 3 surd 2 over 2 surd 3 minus 5 surd 2. To answer this question, recall that a plus b times a minus b equals a squared minus b squared. Hence, for a, 9 minus 3 over 2 plus 3, we can multiply 2 minus 3 for the top and the bottom, and this is what we get: 9 minus 3 times 2 minus 3 over 2 plus 3 times 2 minus 3. Now we can expand the bracket. We get this, and we simplify it, will get 11 3 minus 21 over 5. For b, we can do the similar thing. We multiply 2 3 plus 5 2 for the top and the bottom. And this is what we get: 7 3 plus 3 2 times 2 3 plus 5 2 over 2 3 minus 5 2 times 2 3 plus 5 2. Next, we can open the bracket and simplify. The final answer will be negative 72 plus 41 6 over 38. Now, here is a similar example that you can try yourself. Rationalize the denominator of each of the following: a, 3 minus 3 over 5 minus 3. b, 7 plus 2 over 3 7 minus 4 2. You can pause the video and try to do it yourself. The answer for A is 6 minus 3 over 11, and B is 29 plus 7 14 over 31. Do you get the answer correctly? Equations involving surds. To solve equations involving surds, we need to square both sides to eliminate surds. Example, solve the equation surd x plus 21 equals x plus 1. The solution for this example is this. From the given equation, we need to square both sides, which will become surd x plus 21 square equals x plus 1 square. Surd is eliminated, hence it becomes x plus 21 equals x squared plus 2x plus 1. Now we can solve as quadratic equation, which will become 0 equal x squared plus x minus 20, or x plus 5 times x minus 4. The answer for x is negative 5, or x is 4. Now we substitute the x equal to negative 5 into the origin equation. We get that surd negative 5 plus 21 is not equal negative 5 plus 1. Hence, we reject x equals to negative 5. Let's try this yourself. Solve the equation surd 2x plus 1 equals x minus 1. You can pause the video and try to do it yourself. The answer is x equals to 4. Here is another example. Solve the equation 2 surd 3x plus 3 minus 3 surd x plus 2 equal to 0. Here is the solution. From the given equation, we need to separate the two terms from both sides, which becomes 2 surd 3x plus 3 equals 3 surd x plus 2. Then we square both sides, which becomes 4 times 3x plus 3 equals 9 times x plus 2. We can expand and solve the equation, which becomes 12x plus 12 equals 9x plus 18, 3x equals to 6, x equals to 2. Now we can check the answer. When x equals to 2, we'll get 2 surd 3 times 2 plus 3 minus 3 surd 2 plus 2, which will give us 2 surd 9 minus 3 surd 4, and the answer is 0. Hence, it is equal to the right hand side. X equals to 2 is a solution. You can try this example yourself. Solve the equation 3 surd 3x plus 1 minus 2 surd 5x plus 11 equals 0. You can pause the video and try to do it yourself. The answer is x equals to 5. Equating rational parts and irrational parts. If a plus b sub n equals c plus d sub n, where a, b, c, and d are rational numbers, sub n is a surd, we can compare a equals to c and b equals to d. Here is an example. If bracket 4 minus surd 7 times 3 plus x surd 7 equals negative 2 plus y surd 7, find the value of x and y. Here is the solution. From the given equation, we can expand. We should get 12 plus 4x surd 7 minus 3 surd 7 minus 7x equal negative 2 plus y surd 7. We group the rational terms and irrational terms. We should get 12 minus 7x plus 4x minus 3 surd 7 equals negative 2 plus y surd 7. Now we equate the rational terms and irrational terms. 12 minus 7x equals negative 2. 4x minus 3 equals y. Now we can solve the equations. 7x equals 14, x equals 2. We can substitute the value to find y, which is y equals 4 times 2 minus 3, and the y is 5. Here is a similar example that you can try it yourself. If 3 plus 2 surd 5 times x minus 5 equals negative 7 plus y surd 5, find the values of x and y. You can pause the video and try to do it yourself. The answer is x equals to 1 and y equals negative 1. Do you get the answer correctly? And that's all for this video. Thanks for watching. Do you have any thoughts, opinion, or experience to share? Write it down in the comments. We would love to hear from you. Do you like this video? Please don't forget to like and share to your friends. Until then, see you in the next video. Have a great day ahead.